Do you struggle with handling multiple threads in Java? Ever wished you could pause multiple threads and make them wait for each other before moving forward? Java provides a powerful tool to handle this easily. It's called CyclicBarrier. By the end of this video, you'll not only understand what CyclicBarrier is, but also see it in action with a real-life example and a practical Java implementation. Let's get started. Imagine you are organizing a group trip with your friends. You all agree to meet at a specific point before starting the journey. No one leaves until everyone has arrived. That's exactly how cyclic barrier works in Java. Cyclic barrier is a synchronization tool that allows a set of threads to wait for each other at a specific point before continuing. Think of it as a meeting point for threads. Once all the threads arrive, the barrier is broken and they can all move forward together. In our example, consider each friend as a thread. So, when all the threads meet at some point, then only further execution takes place. Why is this useful? Well, in multi-threaded programs, sometimes you need to ensure that certain tasks are completed by all threads before moving to the next step. Cyclic Barrier makes this super easy. Let's see how to use Cyclic Barrier with Java code example. Create a class which represents a friend and has to perform a task. Define a field for friend's name. Also, we need a cyclic barrier here. This cyclic barrier should be common to all the friends or the threads which need to wait at a common point. So, declare a cyclic barrier field and we will initialize this cyclic barrier inside the constructor of this class. Make this class implement runnable since it will be executing as a new thread. Override its run method. Print a message that I'm arriving at the location along with the friend's name. Add a delay to represent travel time. Sleep throws an interrupted exception, and since it is a checked exception, we need to handle it by enclosing it in try catch block. Print another message after reaching the meeting point. Here, this friend needs to wait. In order to make a thread wait at a certain point with cyclic barrier, call await method on cyclic barrier object. Await also throws interrupted exception and broken barrier exception, which again are checked exceptions, and so we need to handle them by enclosing await call in try catch block. Remember that each thread will pause at the barrier until all the threads call await. Only when every thread reaches this point, they will all proceed together. After all the friends reach this point, print another message for the next step. Now, let's test our implementation. Create a cyclic barrier object using its constructor. The number of threads that should reach the barrier or meeting point is supplied through cyclic barrier constructor. In our example, the threads represent friends. So, let's say the group is of 5 friends. This number is called parties in cyclic barrier terms. Define a loop from 1 to 5 that will run for 5 times. Create a new thread and supply it a runnable object along with the name and cyclic barrier. Since our friend class implements runnable, we can create its object and pass it to thread. Set a name for this object and also supply cyclic barrier. Start the thread. Let's run the program. If you see, all threads start on their own and wait when they call await. Only when all the threads equal to the number supplied in cyclic barrier have called await, the waiting threads move further. Let's see the behavior when we don't use cyclic barrier. Comment this out. All the threads are running in random order. If you see the output messages, all the friends are proceeding to the next meeting point randomly. They are not waiting for each other at a common point. So, now you might understand the benefit of cyclic barrier in the scenario where you need to make multiple threads wait for some action to be performed after all threads reach at a common point. Also, a wait should be called the same number of times as that supplied in cyclic barrier constructor, also called party count. So, if the number of threads or parties in cyclic barrier is greater than the number of threads calling await, then all the threads will keep on waiting forever. Let us check this by decreasing the number of threads to 4. So now, the number of parties in cyclic barrier is 5 and only 4 threads call await. Let's run this. Look, all the threads are stuck after calling await since the barrier was for 5 but only 4 threads called await. Cyclic barrier also supports performing an action after all the threads equal to the count supplied in cyclic barrier constructor have called await. This action is supplied as a runnable object as second argument in cyclic barrier constructor. Create a runnable object as a lambda expression and print a message inside it. Supply this runnable object as a second argument. Remove this print statement. Run the program. See, the action is executed after all threads have called await. You can also pass this runnable directly instead of defining a new variable. I hope the video was useful in explaining the concept of cyclic barrier in Java. Hit that thumbs up button if you like the video, and I'll see you in the next one.